With rising sea levels, extreme weather events, and the threat of coastal flooding, our cities face unprecedented challenges. But what if we could reimagine urban living to not only coexist with water, but thrive upon it? What if we could build a self-sustaining city that handles its own waste, materials, energy, food, and water? This is Oceanix, a floating metropolis in South Korea. This ambitious $600 million project is scheduled to be built between 2025 and 2028. It could eventually house 100,000 people. In this video, we're going to explore how self-healing Biorock or Seacrete could help us realize this movable floating city. We're also going to look at all the sustainable systems integrated into this project. Finally, we're going to examine the pros and cons of Oceanix to determine whether this is the best solution to climate change. Rising sea levels are a reality that coastal cities around the world need to prepare for. Flooding is destroying billions of dollars worth of infrastructure and forcing millions to leave their homes. One of these is South Korea's largest port city, Busan. With a population of over 3.4 million people, Busan is an important economic, cultural, and educational center. Their sea level has risen more than 20 centimeters or 7 inches since 1880. In a bold and progressive move, Busan has teamed up with Biorock Group, an architecture and design firm. Together, they have proposed building the world's first resilient and sustainable floating community. Oceanix is a completely modular and scalable city designed to grow, transform, and adapt organically over time. The city will initially consist of 3 floating platforms connected to each other and to land by bridges. The platforms will be coated with Biorock or Seacrete, a buoyant material that is around 3 times stronger than ordinary Portland cement and concrete. To make Biorock, steel rebar cages are placed in seawater, which is rich in minerals. When a small electric current is passed through the metal, they turn into negative cathodes and positive anodes. Water or H2O breaks down into H2 and O2. Oxygen bubbles form at the anode and rise out of the water, while hydrogen bubbles form at the cathode. Due to the polarity of this reaction, negatively charged anions like chlorine and hydroxyl move to the positive anode. Positively charged cations like sodium, calcium, and magnesium move to the negative cathode. These start to accumulate on the metal rebar, coating it with a thick layer of magnesium oxychloride cement. These fascinating Biorock cables will serve multiple purposes. They will tether the floating Oceanix platforms to the seabed. They will allow the platforms to move up and down, but will prevent lateral or horizontal movement. They will also serve as artificial electrified reefs. High levels of dissolved oxygen around the cathode makes it attractive to fish, reeds, seaweed, oysters, mussels, scallops, and clams. Biorock or Seacrete prevents rusting. All the exposed metal is protected by a thick layer of limestone that prevents corrosion, unlike all other marine construction materials. Biorock is also self-healing or self-repairing. It essentially means that if a portion of the limestone coating is broken off, new material fills the damaged area. Now let's dive into the specific systems of the Oceanix Busan project. Initially, it's going to be made up of 3 platforms spread across 15 acres. Each platform or neighborhood will be solar powered and serve a specific purpose, one for living, another for lodging, and the third for research. Each hexagonal island is around 2 hectares or 3.5 football fields. Floating neighborhoods will accommodate 300 people and feature mixed-use buildings made of lightweight timber and bamboo that are all under 7 stories in height to resist the wind. The Oceanix Busan project will be self-sustaining. It centers around 6 central principles: net zero energy, freshwater autonomy, plant-based food, zero-waste systems, shared mobility, and habitat regeneration. The zero-waste system will consist of a compost garden, anaerobic digester, algae filtration, and an exchange hub. The energy system will consist of solar panels, wind turbines, algae bioreactor, and compressed air storage. The food needed will be grown on outdoor farms, aeroponics, and ocean farms. Finally, the water system will consist of rainwater collection, dehumidifiers, desalination facilities, wastewater and grey water treatment facilities, and water storage. No fossil fuel-based transportation would be found in the city. Instead, inhabitants would use electric delivery cars, boats, and drones. It gets better. Residents would eat a plant-based diet to reduce strain on resources. They would consume around 1,880 grams of food per day. Domestic items would be shared with the community. Any broken items would be fixed at an exchange hub. Oh, and if you're wondering why the platforms are hexagonal in shape, it's because they're inspired by honeycombs. Alright, it's time for a reality check. We don't take things at face value on this channel, so let's cut through all the fluff and really examine this project. When I first came across Bjarke renderings, their ecosystem diagrams, and their questionable attempts at biomimicry, I was turned off. It looks like they threw every possible sustainable system at this project and decided to not filter anything out. There was a lot of mixed messaging in the renderings too. Some images showed a floating city right off the coast of Busan. Other renderings were a cluster of islands seemingly in the middle of the ocean. I was not sold until I spoke to one of their engineers, Matteo Pietrobelli. My podcast with him made me realize that in order to really understand Oceanix, you almost have to ignore the renderings. There are a lot of smart engineers working on this from a very realistic angle. Let's go through some of the positive aspects of this project. First off, it is an attempt to address the very real problem of rising sea levels. Entire communities in Indonesia and other parts of Southeast Asia and even Africa have been displaced due to this issue. Just because we don't deal with it in the States doesn't mean that it's not a real problem. The second argument for floating cities is the use of existing infrastructure.
There are areas for sure in the Midwest. There are areas for sure in more rural areas to build new communities. And those might end up choices for somebody. But for somebody else, coastal cities might end up being the better option because coastal cities represent more or less 80% of the wealthiest city in the world.
Tokyo, Mumbai, New York, and London, the largest and wealthiest cities in the world, are by the coast. Floating cities would be an extension of a metropolis, not an island in the middle of nowhere. Oceanix Busan will be just 50 meters or 160 feet off the coast. That brings us to the third advantage, creating a self-sustaining but grid-tied city. This is a topic I've been passionate about for the past 15 years because it is very doable. Matteo talked about how this project in Busan would be built on a clean slate.
We have the opportunity to start with a blank slate. We don't rely on, say, the legacy systems. If you go on a city like New York, you have legacy systems. You have aqueduct, you have the grid, right? And those are the systems that you rely on. In our case, yes, we can, of course, hook into the redundancy, but those are redundancy systems. The way we design them are designed to actually be completely self-sufficient.
The fourth advantage is that floating cities could be a better solution to increase land area than land reclamation. Those projects can destroy habitats at 2 points, where the sand is obtained and where it is dumped. The process kills marine life and coral reefs that existed there before. Floating cities, on the other hand, can coexist in harmony with life below water. The fifth and biggest advantage I see is the integration of multiple industries. This project brings in experts with a diverse skill set, like people from agriculture, maritime, transportation, and energy sectors. I love seeing construction and architecture industries open up and learn from other fields. But there are questionable aspects to the Oceanix Busan project. Before we discuss them, I'd like to introduce the sponsor of this portion of the video. Brad Hedges is an architectural sales consulting company based in Georgia. They help designers specify terrazzo, stair threads, railings, pavers, and resin wood laminates for architectural applications. They specialize in high-end residential and commercial projects like the Ascent Peach Tree in Atlanta, Georgia. Warm and highly durable Parklex flooring was used in the lobby areas. To complement the wood, removable pavers from Hanover were used in the outdoor areas. Head to bradhedges.com to check out their detailed, exquisite work and contact them for your next project. Let's wrap up this video with the disadvantages of this project. Floating cities won't save us from climate change. Utopian visions like Oceanix that will hold a fraction of the city's displaced population are usually just an expensive and unrealistic dream. I think the better approach would be to extract realistic ideas from projects like these and implement them in every community around the world. Water collection systems, compost gardens, grey water reuse, robust public transportation, etc. can change our cities for the better, and they'd be far less expensive than floating communities. Let me know what you think about Oceanix in the comments. Also, check out my podcast with Matteo. He's a very inspiring person. I'll link it up here. I'll also link my Patreon page in the description. I'm now offering early access to ad-free videos on Patreon as a thank you to everyone supporting me. Don't forget to hit the like button, subscribe button, and the notification bell too. Thanks for watching. See ya.